All right, so this is from exam 2 from spring 2025. This is for Calculus 1 at Oklahoma State University. So the first multiple choice question says, suppose that f is concave down for x between 1 and 3. So we can kind of think about, okay, if that's the case, I have maybe two options. If it's concave down, it might be concave down and increasing, or it might be concave down and decreasing. So we can kind of think about it either way. And then it says the linearization at 1, so that would be the tangent line, is given by this, so that's just the linearization formula. And so then it asks, which of the following is a true statement? So it's asking you to compare the linearization at 3 with the function value at 3. So in this case, when the function is concave down, and I look at f of 3 is here, and the linearization at 3 is this value here. So I can see that the linearization is greater. Let's see if that's true in the other case. In the case where f is decreasing and concave down, f of 3 is down here, and the linearization at 3 is up here. So I can see in both cases, the linearization is greater than f of 3. So the correct answer is B. On the next one, it says, suppose that the function, that function gives the height of an orange that is thrown upward. By solving which of the following equations can we determine the value of t for which the height of the orange above the ground is maximized? So I know that the maximum, at the maximum, the derivative function will equal 0. So h prime of t is equal to 60 minus 32t. And I need to set that equal to 0 to find the critical point. So the correct answer there is D. Here it says, for which of the following limits would it be appropriate to apply L'Hopital's rule? So this is the function is a quotient like that. And so I'm asked to evaluate this. I'm asked to, well, determine which of these limiting values would give me something where L'Hopital's rule would come into play. So if I look at the limit, as x approaches 1 for this function of cosine x plus 1 over x minus pi, so that will be cosine 1 plus 1 over 1 minus pi. So neither of those is infinity over infinity, so 1 does not apply. So to apply L'Hopital's rule, I need to get something like infinity over infinity. For the next one, as x goes to infinity, the denominator will be going to infinity, but the numerator will be bounded. I know cosine gets no bigger than 1 or minus 1. So the top will be bounded, but the bottom will be going to infinity. So B does not work. As x goes to pi, I know that the denominator is going to 0, and the numerator is going to 2, actually, because cosine of pi is, cosine of pi is minus 1. So, yeah, so that one works, actually. It's going to 0 over 0. So what I'm saying is that the limit as x goes to pi of cosine x plus 1 over x minus pi, as x goes to pi, the denominator is going to pi minus pi, and the numerator is going to -1 plus 1. So this is an indeterminate form of type 0 over 0. Okay, let's check to see, well, I know if C works, then I know it's not all the above and it's not D, so the correct answer is C. For the next one, I'm given the graph of the derivative. So this is actually the derivative function. So I'm asked when it has a local minimum value. So I think it's helpful to draw my G prime line. So I know G prime has zeros at x1, x3, and x5. And I know that in between x1 and x3, G prime is positive, In between x3 and x5, g prime is positive. To the right of x5, g prime is negative. And to the left, g prime is negative. And what I'm looking for is when it's below the x-axis, it's negative. And when it's above the x-axis, it's positive. Positive values of the derivative. And so what does that mean about my original function? That means that g is decreasing here, then g is increasing, and then g is decreasing. So if I'm looking for a minimum, that happens here when g goes from decreasing to increasing. So the correct answer is A. So for the next one, it asks me to approximate what value of c is there a solution to this, f of 11 minus f of 6. So I'm looking at 11 and f of 6. So that's here. And so the slope of that is my secant line. And then I want to find a point on here where it has approximately the same slope. So if I'm kind of just eyeballing it, it looks like somewhere around 9 or 10. Let's see here. At 10, it's not quite right because 10 is like that. But the derivative at 9 looks like it is equal to that derivative. So the correct answer is c equals 9. Then it says, suppose that f of 2 is 0, f prime of 2 is 0, f double prime is equal to that, and f of x is defined for all real values. Which of the following is true? So I know that f prime of 2 is 0. So that means that x equals 2 is a critical point. So I can use the second derivative test to see what is f double prime of 2. Well, it's going to be 2 squared times 2 minus 3. So that's going to be 4 times negative 1, so that's negative 4. So that means that the function is concave down at that critical point, which means the critical point is a maximum. So f has a local maximum at 2. And it says, is f concave up for all values in the interval 3 to infinity? Okay, so I know that 2 is true. And so let's see. So if I know that f double prime is that, then I can say f double prime, I could say has zeros at 0 and at 3. Okay. And so where is f double prime positive? Well, if I plug in like 1, for instance, I'll get 1 squared and then 1 minus 3. So I'll get something negative. If I plug in something bigger than 3, I should get something positive. If I plug in something less than 0, like negative 1, say, I'll get negative 1 squared, which is positive, and negative 1 minus 3 is negative, so I should get something negative. So that means that f is concave down, and then f is concave down, and then f is concave up. So f is concave up for all values in the interval 3 to infinity. So that one is true, and there is an inflection point here, but this one is not an inflection point because the concavity doesn't actually change. So x equals 0 is not an inflection point, so 4 is not true. So the correct answer is 2 and 3 only. Okay, on the next one, use calculus to find the critical points of f. State your answers as exact values. Okay, so f prime of x should be 5x to the 4th minus 40x. And then I can, to find the critical points, I'll set that equal to 0. So I can factor out a 5x, and I'll get x cubed minus 8. So I'll get x equals 0 and x equals 3 from that. Then it says use the first or second derivative test to determine if f has a local maximum or minimum at the critical points you found in part A. So let's do both. So the first derivative test, I can look at f prime and see I have 0 and 3. So if I plug in a number greater than 3, I should get something positive. If I plug in a number between 0 and 3, I'll get a positive times a negative. If I plug in something smaller than 0, I'll get a negative times a negative, so that'll be positive. So that means that f is increasing, and then f is decreasing, and then f is increasing. So I should have a local max at x equals 0 and a local min at x equals 3. I could also do the second derivative test, so I can do f double prime of x, and f double prime will be 20x minus 40. And I can plug in my critical points. F double prime of 0 is going to be negative 40. So that means it's concave down, so it's a max. And f double prime of 3 is equal to 60 minus 40, which is positive 20. So that means my function is concave up there, which means that that is a min. So we have a local min at 3 and a local max at 0. So we get the same result. So this is the second derivative test, and this is the first derivative test. So you can do either one here. Then it says use calculus to find the x-coordinate of the inflection points of f. So I went ahead and found the second derivative. I can set that equal to 0. And I can add the 40 over and divide. I get x equals 2. And then I want to check that that is actually an inflection point. I actually did plug in values on either side. So I know that when x is greater than 2, like at 3 for instance, I get something positive. When x is less than 2, say at 0, I get something negative. So that means f is concave down here and f is concave up to the right of 2. So that actually is an inflection point. So that is my, so concavity does change. So it actually is an inflection point. Okay, on the next page, I'm using, doing some limits, and I may or may not be able to apply L'Hopital's rule. And so if I look at the very first one, I can see that L'Hopital's rule does apply because this is an indeterminate form of type infinity over infinity. And so I can apply L'Hopital's rule. So they get the limit as x goes to infinity of 1/3 x to the negative 2/3 over the derivative of natural log x is 1 over x. And so if I do a little bit of algebra, I get 1/3 x to the minus 2/3. So divided by 1 over x would be the same thing as multiplying by x. So this is equal to the limit as x goes to infinity of 1/3, and then I'm going to add the powers. So negative 2/3 plus 1 is going to be x to the 1/3. And so as x goes to infinity, that thing goes to infinity. For the next one, as x goes to 2, let's just check to see if it's an indeterminate form. So on the top, I have 3 times 2 minus 6 goes to 0. On the bottom, I have 2 cubed, which is 8, minus 5 times 2 is so 8 minus 10 plus 2. So that also goes to 0. So this is an indeterminate form of type 0 over 0. So I can apply L'Hopital's rule, and I get the limit as x goes to 2 of 3 over 3x squared minus 5. And so at this point, I can go ahead and plug in 2 because this is continuous at 2. And so I will get 3 times 2 squared, which is 3 times 4 is 12 minus 5 is 7 over 3, or sorry, 3 over 7. Okay, for the next one, as x goes to 1, in the numerator, I get e to the 1 minus e, so that's 0. In the denominator, as x goes to 1, well, the denominator doesn't even have an x in it, so it's just e plus 1. So I'm going to get, this is actually continuous at 1, so I'll get e to the 1 minus e over e minus 1. So this gives me 0 over e minus 1, which is 0. So that one didn't even have an indeterminate form, so we didn't have to apply L'Hopital's rule at all. Okay, for the next one, use calculus to find the critical points of f. So I can say f prime of x equals, and I'm going to use product rule here. And so the derivative of the first is 2x. I leave the e to the x alone. Then I'll have x squared, e to the x. And then I can factor out an e to the x, 2x plus x squared. I'm going to set that equal to 0. And so I get e to the x. I can factor out another x, and then I'll have 2 plus x. So my critical points are x equals 0 and x equal minus 2. Determine the absolute or global maximum and minimum values on the interval -3 to 1. So if I think about the interval from -3 to 1, -2 is in that interval, and so is 0. So I'm going to test all of these points. So I can test f of -3, f of -2, f of 0, and f of 1. And whichever one gives me the biggest y value is the maximum. Whichever one gives me the smallest y value is the minimum. So I'm going to use my calculator to compute these values. So if I do in my y equals, I'm going to plug in x squared e to the x. And then I can graph it, and I can use my trace feature to find these values. So if I plug in if I trace and hit -3, I get 0.448. If I put in -2, I get 0.5413. If I plug in 0, I get 0. If I plug in 1, I get 2.7182. So my minimum is here and my maximum is here. Let's write a sentence to be very clear about this. So f of x has a local or a global maximum value of 0 whenever x equals 0. And I can say f of x has a global, sorry, that was the minimum. I said maximum. Has a global maximum value of 2.7182 whenever x equals 1. And so those are my two, my max and min values. For the next one, I have that a farmer wants to construct 3 identical rectangular goat pens connected to the side of his barn. If he has 200 feet of fencing, what is the maximum total area of the 3 goat pens? So I'm going to label the side links of the goat pens with variable names. So I want to label this maybe W, 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 and I'll label this L. You could have labeled them with different variables if you want, but so there's one thing. Then use calculus to find the maximum total area of the 3 goat pens. So I know the area of the pens is going to be equal to the length times the width, because I'm just really looking at the area of this, this thing here. So it's just the length times the width. But I also know that 4W plus L needs to equal my total amount of fencing, equals 200. So L is equal to 200 minus 4W. So the area is equal to 200 minus 4W times W. So the area is equal to 200W minus 4W squared. So I can take the derivative of that. 200 minus 8W, and then set that equal to 0. So I get W is equal to 200 divided by 8, which is 25, which means my length is equal to 200 minus 4W. So the length is 100. And so I want to make sure that this is actually a maximum. So I can say a double prime of W is equal to negative 8. So that means my function is concave down. So that is actually a maximum. Sorry, my 8 turned into infinity somehow. Okay, so that is a maximum. So find the maximum total area. Oh, okay. So I just found the length and width. So the total area is going to be 25 times 100, which is 2,500 feet squared.